Find the derivative of y equals cotangent of x using the quotient rule. Okay, so what we can do is we can look at our derivative sheet, and I can see that the derivative of cotangent is negative cosecant squared. Okay, so I know what I should end up with on this one. Okay, so most of the time if they say find the derivative of cotangent, I can just automatically say it's negative cosecant squared. But since they said use the quotient rule, that means they want us to change cotangent to sine and cosine. Okay, and then we're going to use the quotient rule to prove why the derivative of cotangent of x is negative cosecant. Okay, so I know from my derivative sheet what I should end up with for the derivative is negative cosecant of x. So the first thing I'm going to do is rewrite cotangent. Cotangent is cosine over sine. We know cotangent is adjacent over hypotenuse. Well, cosine is the adjacent, sine is the opposite. So now for the quotient rule, the top is f, the bottom is always g. So that's going to make f equal to cosine of x, then f prime, so the derivative of cosine, again I'm just looking at my derivative sheet, that's negative sine. Then g will always be the bottom, so that's going to be sine of x. Then g prime, so the derivative of sine, that's cosine of x. Then I'm just going to take all of that and use my quotient rule. So look at your quotient rule, you can see it's g times f prime minus g prime times f all over g squared. So to get the derivative of cotangent using the quotient rule, that means change to sine and cosine, make the top f, make the bottom g, then just plug it all into your quotient rule. So I'm going to have g, which is sine of x, times f prime, negative sine of x, minus g prime, which is cosine, times f, which is also cosine, all over g squared. So sine squared of x. Then I'm just going to simplify. So sine times negative sine is negative sine squared. Cosine times cosine is minus cosine squared. And then sine squared is just sine squared. Then we can GCF out this negative 1. That'll leave me with sine squared plus cosine squared all over sine squared. And then if we go back to our Pythagorean identities, we had 3 of them, but the only one you need to know is cosine squared plus sine squared is equal to 1. So that's what we have right here. Remember, the order doesn't matter when you add. So I know that this part right here is going to work out to be 1. So now my next step will be negative 1 over sine squared. So anytime you have 1 over, that's a reciprocal identity. Okay? And we know that cosecant. Okay? Cosecant is the reciprocal of sine. So that means cosecant squared would be a negative 1 over sine squared because I've got this coefficient here. Well, that's what we have right here. So my next step is just showing that cotangent equals negative cosecant squared. So let's look at another one of these using the quotient rule. So find the derivative of secant of x using the quotient rule. So anytime you see that, that means change it to sine and cosine. So I have f of x equals secant goes with cosine. So that's going to be 1 over cosine of x. Okay. Then I am going to go look at my derivative sheet to see what answer I should end up with. Okay, so I can see secant turns into secant times tangent. So I know what I'm trying to end up with on this one is f prime of x equals secant of x times tangent of x. Okay, and since we're turning everything into sine and cosine, remember secant is 1 over cosine, tangent is sine over cosine. Okay, so this is kind of what I'm trying to end up with so that I can switch it to secant and tangent. So it's kind of like a trig proof. So we've got the top is f, the bottom is g. So f is going to be 1, making f prime the derivative of any constant is just 0. Then g is going to be cosine of x, and then the derivative of cosine is negative sine. And then I can just take all of that and plug it in to my quotient rule. So g times f prime plus g prime times f all over g squared. So we're going to have f prime of x equals g times f prime. So cosine of x times 0, and this is a minus g prime, so negative sine of x, times f, which is 1, all over g squared. So cosine of x squared. Well, 0 times anything is just going to be 0. Negative sine times 1 is just negative sine, so this will be minus and negative. So what I'm left with on the top is positive sine of x over cosine squared of x. Okay. And remember, this is what I'm trying to get to so that I can then rewrite 1 over cosine as secant and tangent as sine over cosine. So since I have different degrees on top, okay, I have degree 1 and degree 2, I'm just going to take that cosine and break it up into cosine times cosine, and then I have that sine on the top. So what I'm going to do is just separate this into 1 over cosine. So it's like we have a 1 up here, so I'm going to take this part together times that part. Because 1 over cosine, that's secant, and then sine over cosine, that's tangent, which is what we know we should end up with. So our final derivative is going to be secant times tangent. So these two that we just did, these are the proofs for why the trig derivatives are what they are. Okay. Now for the rest of them, for the derivative of other ones, they're not going to say use the quotient rule, they're just going to say find the derivative. So when they say find the derivative, we can just look at our derivative sheets and just take the derivative from there. So on number 9, to find the derivative of f of x, I'm just going to look on my derivative sheet. I'm going to see that the derivative of cosecant is negative cosecant times cotangent. So that just means this negative 3 is now going to be a positive 3, and then it'll just be cosecant of x, cotangent of x. You don't have to go through the whole proof unless they tell you to use the quotient rule. So for 8, I can just look at my derivative sheet. The derivative of secant of x is secant times tangent. So that just means the derivative here is going to be 4 secant of x, tangent of x. Then the derivative of cosine, just looking at my sheet, that's going to be negative sine. So that's going to switch this to plus 5 sine of x. And that's all. So unless they specifically say use the quotient rule, you can just look at your derivative sheet and grab the derivative from there. You only have to change it to sine and cosine when it says use the quotient rule. So let's just look at a few more. I'm not going to go all the way through these. I'm just going to talk about how to do the derivative. So on number 11, we have a 4x squared times the cotangent. So this is going to have to be a product rule because I have x times something else with an x. So you're going to make that your f, that your g, and then just use your product rule to solve this one. Okay. This one, since I have a fraction with a trig function in it, I'm going to have to use quotient rule. So the top will be f, the bottom will be g, and then you'll just do your g times f prime minus g prime times f all over g squared. Now this last one, you're not multiplying anything, you're not dividing anything, so you can just go term by term and do the derivative of each, and that would be all.